Hi, it's Mary. I hope you're doing well, and I hope you've been having an amazing summer so far. Because it is summer and a lot of people go camping or hiking, I thought we would make something today that you may have used while you're camping or hiking, and that is a compass. Now, a compass, as you know, works by the needle lining up with the magnetic field of the Earth. So the Earth has a magnetic field with a North Pole and a South Pole, similar to a Bauer magnet. The needle on a compass is magnetized, and usually one end is red. That red end will point north. So we're going to take advantage of the magnetic field of the Earth and create a compass today. We are going to use a few common household items to make our compass. So we are going to use water. We'll use a cup, a dish, a bowl, something of that nature. I am using just a clear glass bowl. We'll use a magnet, and we'll use a sewing needle. So I just moved everything so you could see a little better. So the first thing we're going to do is pour some of that water into the bowl. And it's not going to matter how much water you put in there, just enough so that the needle will float. Next, we're going to take the magnet and magnetize the needle. So I'm going to go along the needle about 50 times. And then I'll flip it over and do it 50 times on the other side. So you can use any kind of magnet you have. You can use refrigerator magnets. You can use, just try to find the strongest magnet that you have. This is the most difficult part of the whole thing. We're going to try to float the magnet in the water. No, we're going to try to float the needle in the water. And I have had some difficulties with this. And so if it doesn't work the first time, that's not unusual. Just keep trying till it does work. The thing I found this morning that works the best is to kind of figure out how deep your water is and just try to lay the needle on top of the water. And see, that didn't work so well. So we're going to try it again. And again. So you want to try to watch so that the whole needle is in the water at the same time. And there's kind of a skin that forms around the needle when it does that. And if you'll notice, it is pointing in a certain direction. And if I move it, it goes right back to pointing in that direction. Not sure if you can see that, so I'm going to actually take the camera off the tripod and move it in closer for a better look. And there's the needle floating on the surface of the water. If I move it, it goes back to pointing in that direction. The wind's starting to pick up now, so it might start affecting the direction the needle's pointing, but if you look at the needle and at the compass, they are pointing in the same direction. So the question is, how does that work? It works because of a couple properties of water. I've got white paper again, so if it is brightly reflecting, I apologize for that. So as you know, or might have heard, water is H2O, which means for every 2 hydrogen atoms, you have 1 oxygen atom. Or for every 1 oxygen atom, you have 2 hydrogen atoms. So we're going to represent the molecule by drawing 1 oxygen and 2 hydrogens coming off of it. So there we are, the water molecule. So the hydrogen atoms are very attracted to one another. They want to bond, which makes water molecules very attracted to one another. We're going to use just a red dot to symbolize the whole water molecule. Better representation of that here. So all the red dots are water molecules. The one in the center is being pulled in all of those directions. The ones at the top are being pulled in a lot of different directions too. But because they're on the top, most of the force for the water molecules on the top is downward. Because of that, we're able to float things on top of the water. So for the water molecules at the top, the net force is downward force. If you've noticed with water, even when we were putting that needle in there, it kind of forms like a skin around the needle. And that's kind of the force that holds it up. So what have we done today and what have we learned? We created a compass using the Earth's magnetic field and the quality of water that causes it to attract to itself, which creates surface tension, which we can use to hold up long, narrow items. So I hope you enjoyed this activity. If you did, this is like a branch of science that it's a physical science, physics. If you're interested in learning more about Earth's forces, or you're interested in exploring Earth's forces, physicists, being a physicist or studying physics is a good way to go. Physicists don't only study Earth's properties, there are astrophysicists that also study properties of other planets. Thank you so much for your time today. I hope you enjoyed making a compass and learning about the magnetic field of the Earth and surface tension of water. Have a wonderful rest of your summer, and we'll see you next week.